operations that can be carried out when you have two functions. So suppose we have function fx and gx, okay? Whatever the definition can be for these functions, it doesn't matter. So even if you have those two functions, you can add those two functions by addition, okay? You're going to see that as we solve some questions. You can subtract those two functions, so subtraction exists. You can also divide, so there is division there with the notations as shown here, okay? There's also multiplication of functions, so two functions or even three can be multiplied, okay? And these are the notations used there. Now the other notation which is used for multiplication of two functions is like in this case where we have function fx and gx, multiplication can be denoted by f, g, then x inside the brackets. So let's see how that applies as we solve our questions here. So our first question, we want to find f5, okay? So this is what we have here, f5. So look at the function that we have, okay? The function that we have here, where there is x in the function, this is our original function, okay? So this is our original function here on top. Now let's just put it here, okay? So in our original function, we have fx is equal to 2x minus 5. Now what we want to find is f5. So that means we are going to substitute x, okay? X by 5. So we have f5 is going to be, we have 2 there. You open your brackets and substitute where there is x by 5, okay? And that is going to give you 10 minus 5, which will just give you 5, right? So this is the value of f5 for your function. Now we can go to B and find the inverse. So I want to find the inverse of x. So I want to find the inverse of this function x. So if you remember from the definition of an inverse function, you better know what to do here, okay? So to solve that, we are going to let y is equal to the function, which is 2x minus 5. Now what we are going to do here, we need to solve for x. So we are going to have, that's 2x is equal to y plus 5, right? That's y plus 5. Now to solve for x, we are going to divide both sides by 2, and that will give us x is equal to y plus 5, right, over 2. And now we can write that, okay? Therefore the inverse of function fx, right? So the inverse for our function fx is nothing but, so we are going to substitute y by x plus 5 over 2. So this is our inverse function, okay? So that's it. That is x plus 5 over 2. And now we can solve question C. So question C, we have f(x) inverse. Now what does that mean? So from the definition, this means that we are going to multiply our original function, which is fx. Now fx will be multiplied by its inverse function, okay? So this is what the notation means. Okay, so we are just going to substitute our fx. So our fx function is 2x minus 5, right? It's 2x minus 5. Okay, so this is 5 there. Now this will be multiplied by, look at our inverse. We're just from calculating the inverse, which is x plus 5, okay, over 2. So this is what we found as our inverse function, okay? Now we are going to multiply. So if you multiply this, you are going to get okay, let me just write this. We are going to get half, okay, you're going to get 2x. Okay, so that's 2x squared. That will give you 2x squared, that is 2x by x, and then 2x by 5, that is going to give you positive, that's 10x, right? That's positive 10x, so this is 10x there. Okay, now negative 5 times x, that will give you negative 5x, right? And now negative 5 times negative 5, that will give you negative 25, right? So this is going to give you negative 25. Okay, so even close your bracket. Now if you do that, you can proceed and get the original answer. So there we have 2x squared, right? So we have 2x squared. That's positive 10x minus 5x. That is going to give us positive 5x, right? Now we have minus 25, right? So we have minus 25. Okay, so this is what we have. That's our the fx, that is a function multiplied by its inverse. Now we can solve D. So you just need to understand what the notation means, and you can solve any question. Okay, so the question we have for D is f inverse 2. Now what does that mean? So that means we need to take the product of a function and its inverse and substitute x by 2. Okay, so we have this. Okay, f, look at this, f inverse x, right? f inverse x is the function that we just got, right? So this is the function here. Okay, so let's just copy this. Okay, let's hope you'll be able to see that. Okay, so this is the function here. Let me just copy it so that you can see it, how we'll be substituting. So this is our function. This is what we have found. Okay, this is what we have found to be our fx inverse. Okay, so that's our product. Now this time what we have is f instead of fx inverse, this time we have f2 inverse. Okay, so we have 2 there. This means in this new function we have, which is a product, we are going to substitute there. So we have 2, you open bracket and substitute x by 2, then plus 5, we substitute that by 2, minus 25. Okay, now you are going to get you're just going to get, that will be, if you do that, we're just going to get, that's 4, right? So that will be 4 here plus 5 that's plus 5 minus 25 over 2, right? Yes, this is what we are getting. Okay, you can confirm that. Yeah, you can pause the video and just try to confirm. Okay, all right, so we can proceed here. So this is what we have, and next here, this means we have 9. Okay, so we have 9 minus 25 over 2. Okay, now so solving this, you can find your lowest common denominator and solve that. So if you do that, you are going to have, you're just going to have 18. Okay, just going to get 18 minus 25. Okay, it's going to get 18 minus 25 there over 2, right? I'll make sure I confirm this, okay? But this is what you should get. And now if you do that, we can just say our f inverse 2 there is equal to, so what are you getting there? So you're going to get 21. So you're going to get just 21 is the whole number, okay? That's 21. Now 1 over 2. So you're going to get a mixed fraction, okay? Or what you are getting is okay, so 43. Let's do this. Okay, so just like this, this will be okay. Wait, is this what we are getting? Sorry, I'm looking at something else here. Okay, now if you check what we have here, this is 18 minus 25 and not plus 25, so definitely this is not what we are getting. Okay, so what we are getting here, okay, let's just highlight this. So what we are getting here is we have 18 minus 25, that will give you negative 7 divided by 2. Alright, so this is what we are getting. Okay, or if you don't want to write this, you can still write this as negative 3 whole number, then you're going to remain with remainder 1 over 2. Okay, so either way this will be fine. Okay, all right. Now we can solve this one. Since we have the knowledge from the previous video, now we can solve example 2, or let's say question 2. Now in this one, the function we have is hx. Okay, so we have hx is equal to 3x plus 2 over 4. So the first the first question is we need to solve for a2, right? So that means we have h negative 2. So this means we are going to substitute our x by negative 2. So we're going to have that's plus 2, right, over 4. Now if you do that, you are going to find that you're going to have negative 4 over 4, which will just give you negative 1. Okay, so negative 1 is what you are getting. Now b, we can go ahead and solve b. So in b, we want to find the value of x for which hx is equal to 5. So I've been given to say hx is equal to 5. So you just have to substitute here our hx. We have our hx, which is 3x. So we're just substituting. So we are told this 3x plus 2, okay, over 4 is equal to 5. This is what it means. So we're just substituting. Now if we do that, you're going to find that multiplying what you have is just going to give you 3x plus 2, right? So that will be 3x plus 2 is equal to 20, right? Okay, so 3x plus 2 is equal to 20 is what you are getting. Now you know that 20 minus 5 minus 2, I mean, you are going to get 3x, right? This will be 3x is equal to 18, isn't it? So this is 3x and not 2x. So dividing both sides, okay, by 3 and apply cancellation rule, we are going to get x is equal to 6. Okay, and now we can go ahead and solve the inverse of x. So I want to find again the inverse of x. So this is our C. Okay, so we're going to use the same procedure we used in the first question. So we're going to let y, okay, is equal to 3x plus 2, right, over 4 over 4, right? So here we're going to cross multiply. We're going to have, that's 4y is equal to 3x plus 2. Now we need to solve for x. So we are going to have 3x is equal to 4y, right? 4y minus 2. Again, solving for x is going to give us x is equal to 4y, right? That's 4y minus 2 over 3, right? Okay, so this is what we have. Now we can safely say f, sorry, not f, that's, we're dealing with h. So h inverse of x, so hx inverse, the function of hx, the inverse function of hx is equal to 4. So we're going to substitute 4. We're going to substitute y in the 4y by x. We're going to get 4x minus 2 over 3. So this is the inverse function of fx. Okay, so thank you.